Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, as we continue on with CompTIA Net Plus. This episode is Classless IPv4 addressing Part 4. And Wes Bryant is here once again to take us through it. Wes, great to have you here. Thanks.
Hey, thanks for having me back. Yeah, this is the never-ending episode, but there's a lot of concepts that we have to talk about, especially when it comes to things like subnetting. We talk about things like classless interdomain routing, notation, CIDR notation. So we've actually looked at a lot of different things here as we've gone through these 4 parts. So if you're not aware of some of those topics, definitely go back and watch the first 3 parts, and then come back here and join us in Part 4, because this is really going to be a continuation, and we're picking up right where we left off. In fact, if you remember, in the last part, the last episode, right at the end, if we could take a look at the question, we were looking at a few answers, right, that you could potentially see on the exam, and we narrowed it down to this being the right answer, that if we needed 5 networks, 28 hosts per network, right, what kind of slash notation or subnet mask would we need with the base information of 209.123.221.0, and we provided that, right? We found out that a subnet mask of 255.255.255.224, or just a /27, would give us, and we went back over to our trusty Excel spreadsheet here, and we looked at borrowing those 3 bits, right? 224 is in that last octet, would give us 8 networks. And then we counted the host bits up, right? We said, okay, if we've got a certain amount of host bits, right, 5 of those host bits, if we did the math on that, right, we come out here to our calculator, and let me go ahead and just change this to a scientific calculator, right, and we do a 2 to the power of 5. We see that that gives us 32 possibilities. Remember, we cannot give the first and the last address, so that's 30 overall hosts that would be on each of these 8 networks that we created. So we did accomplish our goal, right? We have 2 extra addresses per network, right? 28 hosts is what we needed. We got 30. So we have done the first part of the question. Now, I've kind of added on to this question because there might be some other things that they ask you in the context of just general subnetting to see if you understand where the broadcast and the network IDs stand, and then you can find out if an address is actually addressable within a certain network. So we want to go ahead and we kind of want to move into that next. So the next part of the question we're going to ask here is, well, what are the individual network, or excuse me, what are the network IDs for the individual networks that we've created, all right? And then we'll come back and we're going to look at a couple other things. We're going to look at the broadcast addresses, and then finally, the last thing that we're going to look at is we're going to look at what is the addressable range for the host, right? These are all questions that you might see, types, right, that you might see on the exam. So we want you to be prepared, and we want you to have a clear understanding of that. So remember that we said if we needed to find out what network IDs are, right, all we have to do is take these 6 networks that we've created. Remember, we can go ahead and we are working with this, oops, sorry about that, this CIDR notation right here, right, 209.123.221.0/27, and that gave us these networks right here. And remember that I told you that once you know what your network bits are, right, you've got a certain amount of network bits that are just going to stay the same. Like I know the first 3 255s, all ones. I don't have to worry about anything within that range. I just have to focus on that 224. Well, once I've established that those 3 bits are now part of the network portion, now all I have to do is come back here to the host portion, right, our dividing line, and just basically put zeros in every one of these fields. And what that'll do is that will show me what our network IDs are, right? And then we take these out of binary, which we're going to do. We're going to do this for every one of the networks here. Again, give you multiple examples, and then what we want you to do here is as you are practicing this and getting ready for the exam, we definitely want you to be practicing this as well at home, but this should give you plenty of examples that you can be on board with. And again, like I said, should make it easier for you should they ask you on the exam. So now that we've got our zeros in the host or node portion filled out, remember that it's just a matter of taking these numbers and putting them back in decimal form and then attaching them to that last octet, because that last octet is really where the action's at, right? Octet isolation. If I'm worried about subnetting, I'm only going to focus on the octet that we're actually borrowing bits, right? So we can take this out and we can see that the first network ID, if you will, is going to be, what is it going to be? It's going to be 209.123.0.0, oh, I missed one octet, sorry. 123.221.0/27, right? So that's always going to be the first start, right? That is essentially where you start with any kind of subnetting. You're going to at least have that very first base address, which is 0. Then we're going to go ahead and we're going to move to the next octet, right? And we have to figure out, well, what is this next octet, right? Well, I can kind of see that since there's only a 1 in the 32-bit position, right, that place value, well, that's going to be the number, right? Because to take it out from the binary to the decimal, we just add up all the ones. Well, I've got one 1-bit right in the 32 place value, right? So that's going to be 209.123.221.32 and / again 27. All right, now we're going to go to the next octet. We're going to see, well, what's the network ID for this one? Remember, all zeros in the host bit, take this out of the binary, put it back into the decimal, and we have 209.123.221, and in this case, it is .64 / again 27, just to keep with our CIDR notation. All right, so then the next one that we have here is going to be, well, notice that there are 2 bits, right? We have the 64 and we have the 32. So if you need to, you can always get out the calculator. Remember that you know, and even on the exam, by the way, let me let you know that they will bring you a calculator out. So if you don't know, have that calculator ready to go. And then you can add your 64 and your 32. We get 96. So I can see that the next octet, or the next network, if you will, is going to be 209, and this will be .123.221, and again .96, and then a / 27. All right, moving down to the next network, right? We're going to do a 209.123.221.0. Notice that there's only a single 1 in the very first bit position, making that 128 for that network's network ID, if you will. Now again, following down, notice that there's a pattern here. Nothing's really changing, right? Now we've got a 128 and a 32, and I'm not even going to prove to you how bad my math is, so we'll do 128, and we'll do plus 32, and that gives us, well, 160. So we can tell that the network ID for the next network is 209.123.221. And again, let me just double check myself as a 160. Thank you there, Mr. Zach. Appreciate it. And again, a / 27. All right, now moving on down, right? We've got 2 bits. You should recognize these. If you've been following along with us, you should recognize these as one of those valid subnet mask ranges, right? Because there's 2 bits, 2 1-bits here. Remember, 128, 192. So I don't even have to count this one out. I can see that this is 192. 209.123.221.192 / 27. And then the last one is, well, 3 bits. All right, and we look at the 3 bits there. Well, I can tell that that's 224. And again, because of those counting those consecutive bits, those contiguous bits, you'll start to see that pattern come up.
Going back to a chart that you made.
That's right, absolutely. 123, so it's 209.123.221.224 / 27. All right, so we've got what? 1, 2, 3, 4, 5, 6, 7, 8 networks. Remember, there's 8 possibilities. And how did we come up with those 8 possibilities? Well, you can do the math if you want on that one as well. And if we bring back our calculator and we clear this out, we can do 2 to the power of 3, those 3 bits. And notice that we have 8 right there. So you can see it's always an exponential value. Just 2 to the power of however many bits you have. If you're talking about network bits, that's how many networks you have. 2 to the power of however many bits if you're talking host. That's how many hosts you have, and then minus the 2. One of those 2 being the network IDs that we're working on right now. Now, we also have to look at the next part of the question, all right? If we know now what the network IDs are, the next part of this would be what are the broadcast addresses? And let me go ahead and use a little bit better English there so my math teacher isn't mad at me. Or not math teacher, that's probably why it's mad at me and I can't spell. I was in math learning English. That's right, my English teacher. So what are the broadcast addresses for these networks? Well, remember what we're going to do here is we're just going to take every single one of these place values, right? And we're just going to essentially make every one of them 1s, right? So we'll do that, and we'll make those 1s 1, and again 1. You can kind of see the pattern here, because in the host bits, right, all 1s say, hey, that lets me know right away that that is going to be your broadcast address. Notice that all we have to do now, again, that's why these place values are so important, and if you can remember them, just remember that write them down the moment the test starts. Write this little chart down, and you should be doing well for the exam when it comes to figuring out problems like this, all right? So now that we know what the network IDs are, let's go ahead and we'll put these, take these out of the broadcast, out of the binary and convert them into decimal. All right, our very first one is going to be 209. If you want, you can always do the math here. With me at home, you can pause it, but the very first one is going to be 209.123.221.31, and again, we'll do our /27, just so we keep it consistent. Next one is going to be 209.123.221.63, and again, /27. All right, you'll see 209.123.221.95 for the next one, and again, if you wanted to add this up, you would see that that comes out to 95. All right, so that is the broadcast address for that network. And again, next one's going to be 209.123.221, and that next one is going to be .127, and again, /27 as well. All right, our next one, the broadcast address will be 209.123.221, and that will be .159, and again, /27. Again, just moving down the list here, like I said, if you need to pause this, you need to compare those bits, and you actually want to add them up, by all means, go ahead. The next one, it is going to be a .191 in the last octet for that broadcast address. Then we have 209.123.221. 223. You got it. Very good. Thank you there, Zach. Do appreciate it. And the last one, of course, is going to be the highest one in the list. All right, all 1s, and by now we know that all 1s is the largest number that you can have in any octet, so that is going to be 255. And again, /27. So what we've done is we've solved the problem of what are my network IDs, right? So here are our network IDs right here. These let us know what networks these computers would belong in, all right? And these are our broadcast addresses. These let us know on each of these networks where we send our broadcast communications, all right? So the last part of this question here, just to kind of take this into completion, is what is the addressable range for the host, right? Now that we know what we can't give, right? Remember, we can't give the first possibility. I don't even want to call it address because the first possibility is the network ID. The last one is an address, but we still can't give that out because that's a broadcast address. Now we have to figure out, well, what is in between. All right, let's go ahead and do that. Keep in mind that it's kind of simple. +1 on the network IDs, -1 on the broadcast gives you what your addressable range is. And we're going to do this like we did before. We'll do .1 through .130, or excuse me, .30s. All right, and there is our 30 computers. All right. Now, the next one that we are going to look at, we've got 31 or 32 for a network ID, and again 63 for a broadcast address, and again that's in that last octet, so that is going to be .33 to .62. All right. And then moving down the list, we have .65, and again, that's because it's one past .64. .64 is the network ID, and then .94 for those nodes on that network. Then we have .97 through .126. For the next network, you'll see we have .129 to, thank you, Excel, but you're wrong, to .158. It really is. It really wants to help me, but it would help me just by staying out of my way. .161 for the next network is the first address, and then the last address that we can give to hosts is .190. Again, .190. If I can get my cursor to get in the right spot there. Second to last network, we've got .193, again, because we can't give .192, that's the network ID. Then we have 223 here, so we can't give that out, so it's .222. Last but not least, yes, drum roll please, we're going to say last one is .225 through all the way up to .254. All right? So we've done three things with this, right? We've identified and solved for the fact that on this problem, yes, we did provide 5 networks with 28 hosts. We need to provide additional networks for the future. We accomplished that. So we've got our 5 networks, we've got our 28 hosts, and we've got 3 additional networks that we can use in the future. Then we solved for, well, what are the network IDs for these individual networks? And we solved for that as well. What are the broadcast addresses? And you have to know those and you have to know how to figure them out, because they might just give you a slash notation like we have right here, and they might say, is this a valid address, host address? Is this a valid host address? It is a valid address on the network, but it's not a valid host address. And you would have to know why that is not a valid host address. And again, that's because of the fact that, well, it's a broadcast address, right? And then the last part is we found in the question was not only what are the broadcast address, but what is the addressable range for the host there. My head's kind of covering it up there, but there we go. What is the addressable range for the host? That was the last thing that we solved for, and, well, guess what? We've done that. You've seen the ranges. You've seen how we come up with that, seen how we come up with it in the binary, and then how we move it from the binary back into something that we can actually, us as humans, can read a little bit easier, back into the dotted decimal notation. Now, one of the things that I want to mention to you is this is what's known as a fixed-length subnet mask, and why I say that is we had a network range, all right? And within this network range, we're using a single subnet mask. All right, now the subnet mask is classless in the fact that we don't have the 3 default classful subnet masks, 255.0.0.0, 255.255.0.0, 255.255.255.0, right? We've kind of manipulated the bits, but it's still a single subnet mask, all right? Well, you can go a little bit farther than this, and you can actually shrink and divide the networks into the ranges and only those ranges that you need, basically reducing the waste even more. Let's show you how you do something known as variable link subnet masking, all right, VLSM. All right, so got another question here for you, and let me figure out where it is. Okay, so here we got a question, all right? The question is, you are a network administrator for the demo.itpro.tv and been tasked with designing the network subnets for the team. You've been giving the following information, all right? So we're starting out with just a Class C private IP address, all right? Now, notice that we have the edutainers group is going to need 28 hosts. The marketing group is going to require 100 hosts. The sales group is going to require 42 hosts. And then last but not least, the managers group requires 9 hosts. All right. Now, what are we required to do? All right. Well, we're required to provide the CIDR notation for each subnet using the least amount of bits for each network with the required amount of hosts. All right, and this is what variable link subnet masking does. It means I can start with a base address, and I can use different subnet masks to put just those hosts within the subnets that I want, right? Varying the length of the subnet mask. So how would I go about doing this if I needed to approach this on the exam? All right, first of all, we have to understand what the keywords are here. And the keyword is you need the CIDR notation, right? And the least amount of bits for each network but you also have to have the required host. So we have the least waste, right? And that's really what it comes down to when we talk about variable length subnet masking, right? Is the way to tailor make and customize your network so that you don't have additional waste, all right? So how would I attack this, all right? Well, the first thing I need to do is I need to figure out what is the largest pool of hosts that I need, all right? Because what you want to do is you want to make sure that there aren't overlapping networks, right? In variable length subnet masking, you are creating individual subnets, but you really just don't mix and match, right? Things just become crazy that way. So what I like to do, and what a lot of people will do, is they'll start with the largest amount first and say, how many nodes or how many bits do I need to accomplish the largest network or the largest subnet? So in that case, you can see that what I would do here is I would rearrange these right away in my head. I'd say, okay, marketing group requires 100 hosts. That's the biggest, all right? And then the sales group requires 42 hosts, so that's the next one in line. All right, and then what we're going to do is the edutainers, they're third in line. They have 28 hosts that they need. It's kind of funny. Sometimes we call ourselves hosts. We like to call ourselves edutators because we try to educate and be funny and, you know, try to entertain you at the same time. But it was kind of funny. I originally put hosts, and I was going to say the host group needs 28 hosts. Well, that was a little redundant, so I changed it to edutators here. All right, and last but not least, managers. Managers aren't going to be consuming a lot of the network hosts that we need here, but we can see this would be the first thing I do. Again, arranging these largest to smallest. Now what I need to do is figure out, well, what's my base address? All right, well, my base network address is 192.168.0.0. All right, if you remember, with 24 bits, that tells me that the first 3 octets, essentially if this was a subnet mask, it'd be 255.255.255.0. That lets me know right away that the first 3 bits are going to be part of my network. All right, and when we talk about being a part of our network, I don't care about those bits. I only care about this last octet. So that's where the action is, and that's where we're going to do our subnetting, and that's where we're going to apply a variable length subnet mask to each one of these networks. So let's start by figuring out how many bits in this network do I need to get 100 hosts within a single subnet. Well, if you remember here, we can go back to how many bits it requires to get this amount. Well, what's kind of interesting is if you notice that 128 number, if I was going to make a network with 128 nodes, I would know right away by that by counting the host bits more than anything here. Let me go ahead and just delete our line here because we don't really need it right here for this example, and we will do a no fill on that. All right. I say that, there we go. All right, so what I need to do is I need to figure out, all right, in this, in these amount of bits, what does it take to put 100 nodes on a network? Well, remember I said that if you're looking at network bits, it's 2 to the power of however many bits gives you this amount of subnets, all right? But we used a fixed link subnet mask, all right? Now what I want to do is I'm going to focus on the host bits, right? I'm going to focus on the node bits and see how many bits it takes me, right? All right, my guess is that it's going to be 7 bits, 7 host bits, which means 7 zeros that I need. I don't know. Is that right? Well, we can find out. If we bring up our calculator again, let's go ahead and let's do exactly that. Let's go ahead and do a 2 to the power of 7 equals, well, 128 minus our 2, right? Because we can't give 2 of those out. That lets me know that that is going to be how many bits I need to give me 100 hosts within a network, right? So what I can do here is quite literally I can say, all right, well, I know that in doing this, and I tell you what, let's go ahead and let me quit zooming in and out here, try to make it a little easier for you guys to see that. I'm going to go ahead and I'm going to be a glutton for punishment. What we're going to do is we're going to take all of this and we're going to get rid of it. All right, so if I want to have 100 hosts, right, I know that I'm going to need a 192.168.0.0 slash, and that would be a slash, what would it be, 25, right? Now, why is it a slash 25? Well, we just determined, right, that how many bits would I need for the host bits? Well, that was 7. So that's 7 zeros. That leaves me 1 bit that I'm going to turn into, if you will, a 1. All right, and let me go ahead and just kind of reset some of these here real quick. All right. There we go, and we'll just kind of work with these. All right, so /25, 255.255.255 dot, well, 128, right? That is 1 bit turned on to the network there. It gives me a 128. Now, I need to figure out how many networks did that make? Well, if you remember earlier, we showed you how to determine that, right? I know that actually makes 2 networks. All right, so I know that the 2 networks that we've created here is going to be 192.168.0.0, right? That's the first one, network, right, with a /25. I also know that the next network is 192.168.0.128, right? If you remember, we've actually subnetted this before where we had a 0, that first network range, and then the second network that we created was a 128, and that's because you can do it in the binary. Remember, if you're not familiar how we got those possibilities and combinations, definitely refer back to the earlier portions of this show. All right, so these are the 2 networks that we have, all right? And that lets me know that, yes, I can get 126 hosts on that one network, all right, which accomplishes my 100 hosts, right? Now, here's where you start to vary the length, all right? These 2 networks, right, since I could put these on either one of these networks, right, with a /25. But the problem is, in creating those 2 networks, I have to pick. Am I going to put those in that very first network, or am I going to put them in another network? Well, for me, I'll go ahead and I'll leave this first network that we've created, I'm going to leave it alone, all right? Because what I'm going to do now is I'm going to take another portion of that address, or that network range, 192.168.0. Let's see here. So now, I tell you what, I'm getting ahead of myself, all right? So I've got my 100 hosts. Let's switch back over, all right? Notice we got our 100 host. Well, what is the next address that I want to give, right? Well, I can't give out the network of 128, right? Because that's part of this subnet mask, right? So the next thing I'm going to do is I'm going to go ahead with a 62 host, or I say 62 host, excuse me, 42 hosts, and I'm going to figure out how many bits do I need in order to accomplish 42 hosts on a network, all right? So what I'm going to do is, since I'm going to put those 100 computers, if you will, I'm going to put those 100 computers in this very first network. Well, that means I still got this other network that I can work with. So if you look, I can do, starting with 128, since I'm not using that network, I could say, hey, I'm going to use a 168.0.128, right? Because we're not using that network. And what I'm going to do is figure out how many bits do I need to make 42 hosts, all right? Well, 32 is a little bit too, isn't quite enough, right? So how many bits, how many zeros do I need to make those 42 hosts? Well, let's count. 1, 2, 3, 4, 5, 6, 7. Well, let's see. Do I need 7? Well, I don't need 7, right? Because if I turn just the 1 bit on, right, and that makes the rest of those host bits, well, that's what we already started with. So that's a little bit too much, right? There's a lot of waste there. We don't want any waste. So what about if I make 2 of these network bits? Does 1, 2, 3, 4, 5, 6 bits? Does that give me 42 hosts? Well, I don't know. Let's go back to our calculator, right? And if I do 2 to the power of 6 and do an equals, well, that gives me 64. 62, because we can't give the first and the last address, right? Well, is that too much waste? Well, I'm not sure. Let's see if I reduce it even more, and I say not 6 bits. Let's say 5 bits, all right? So we'll do 2 to the power of 5, and we'll say, all right, let's figure out what that equals. Well, that equals 32 minus the 2 is 30, so that's not enough, right? So that isn't as many as I need. So I can't use 32. That means what I need is I need those 6 bits, right? Again, because those 6 bits, 2 to the power of 6 equals 64, that gives me the 42, and that's the smallest I can make it I can't make it any smaller or I don't have enough bits. I wouldn't have enough host addresses. So what I'm going to do is I'm going to go ahead and I'll do a /26 on that network, starting with the 128, the one that we aren't using for the 100 hosts. All right, so I'm going to do a /26 here. And what that does is that gives me /26 will essentially give me it gives me 62 hosts, right? We've already seen that because I can't give the first and the last, but that also allows me to accomplish my goal of 42 hosts on that network. All right, so there we go. All right, we've accomplished 42 hosts for the second network. Well, now we've got the third network that we need to figure out. How do we vary the length of the subnet mask yet again to create another network, right, with these 28 hosts? All right, well, that means I have to figure out what is the broadcast address for this network, all right? Well, to figure out the broadcast address for this network, we would have to go through the process of putting, finding out where the dividing line is, right? Making sure that all our host bits are turned into ones, and then we take it back out of the binary and we figure out what that decimal value is, all right? Well, I can tell you the broadcast address with this, I know we're kind of running out of time here, but just to kind of move it forward, and again, you can stop and take the time to do this, is actually 192.168.0, and that is a .191. All right, 191, and let me see with my calculator, 128 plus, oops, clear that out, 128 plus 62, 128, no, actually plus, oh, darn it, we'll get this right eventually, 128 plus 64 equals 192, all right, and if I take that out, all right, so basically what I'm doing to figure out what the broadcast address is essentially just going ahead and taking that, that 128, which counts as a possibility, so I got to kind of take it off and do a plus 63, and that gives me 191. Easy way, very easy way to find the broadcast address, right? Because once you know how many nodes that puts within that network, I just take 128, you got to subtract that one because you're using that possibility, and then however many possibilities are left, just add it. That tells you what the broadcast range is. A little shortcut there that you can do, but again, that tells me that 191 is the broadcast address. And remember that I can't give the broadcast address out. That lets me know that the next network that I have to work with is 192.168.0.192, right? So that's the next network ID, right? If this is the broadcast address for that network, that means the following address has to be the network ID for the next network in line, right? All right, so we've taken care of our first two networks, right? We've got our 100 host, we've got our 42 host, right? And we have reduced the amount of waste. Next thing we have is we need to figure out how many host bits do we need if we are going to put make a network that needs at least 28 hosts, all right? So let's figure that out. How many bits do I need if I'm going to create a subnet that needs 28 hosts, right? Well, all I have to do is figure out how many bits do I need, all right? So I'm gonna kind of take a guess here, and I'm gonna say, you know what? I think I need 1, 2, 3, 4, 5 bits, and we did this just before. 32 is what that's right. So if I look, I say 2 to the power of 5 equals 32. Well, guess what? I know that's my answer because minus 2 gives me 30.
That's right.
28 fits within that range, right? So what is if I have 5 1 bits, and I'll just go ahead and do these right here. If I have 5 1 bits, oh, not 1 bit, excuse me, 5 0 bits is what I meant. I should have just left them alone. All right, that means that in order to make that happen, I have to turn these into the 1 bits, right? That'll be a portion of my network, and that tells me essentially what the subnet mask is going to be in that last octet, right? 1, 2, 3. That's 128, 192, 224. So I can tell right away that in that last one, I'm going to go ahead and I'm going to put 224, that's 3 bits. So what is that? 24 plus 3, that's going to be a /27.
Yep.
All right, so 192.168.0. What did we say? 192/27. All right, well, that gives me those 32 hosts. And if I do like that little shortcut I told you, if I turn out my calculator and I say, okay, so what's 192? That's one of the possibilities, so I can't use 32. I got to subtract one of the possibilities there, plus 31. Oops, and that is not right. Let's try that again. 192 plus 31, the remaining possibilities, tells me that 223 on that network is going to be the broadcast address. All right, and again, you can take the time to do the binary if you want. By now, you should be able to figure out how to do the binary, but we know that that is the broadcast address, and I'm trying to figure this out so I know what the next network's going to be, right? So there's a couple of things that I'm doing here in doing this. What I'm doing is also finding out what is the next network ID that I get to work with. So this is going to be, oops, if I can get the octet right, 192.168.0.224, and then we'll worry about the slash notation coming up. All right, so remember, 30 hosts on this network gives me the 28 that I need, and I have very, very little waste. Now that I know that I'm working with a 224 for my next network ID, all right, I've got a few possibilities, right, that we still need to work on, right? I need a managers group that has 9 hosts in it. Notice how we're working, and we're doing this basically in a continuous fashion with no overlap, right? So each network is separate, and we're working with the overall pool of addresses we have, and we're dividing it up using variable length subnet mask to put those nodes within the networks specifically that we want to create. All right, so how many bits do I need for 9 hosts? All right, well, let's go ahead and let's try 3 bits, all right? Let me see. So if we do 1, 2, 3 of these host bits, right, let's go ahead and clear our screen. Let's do 2 to the power of 3 equals. All right, well, I need 9 hosts, right? I've got 8 here, but I've got to subtract 2. Well, that really only gives me 6 hosts. I know that 3 bits isn't enough, right? So let's go ahead and say how many would 4 bits work? Well, 2 to the power of 4 equals 16. Well, is 16 enough? Well, minus 2 gives me 14. I only needed 9 hosts.
A little bit of waste,
but it's as short as we can get, right? Because if I go any more, then we got 32. We're back up to 32, and that's way too much waste. So I can see that if I have 4 host bits, right? 1, 2, 3, 4. Then I'm going to turn the rest of these bits into 1s, and that becomes the subnet mask for the final network, right? So what's the slash notation? 24 is already reserved, 255.255.255, so I already got, remember those baselines, I already got slash 24, so plus 4 is going to be at slash 28. All right, we do a slash 28. All right, and well, that ends up giving us our last network, and that puts, what we say? We said that's 16 nodes. So if I want to figure out what the broadcast address is with a slash 28, I'm just going to go ahead and do a 24, right, plus, I can't use 16 because 224 is one of those possibilities, so plus 15, oops, you got to do the rest, Wes. 224 plus 15 equals 239. So I can see that on this network, the broadcast address is 168.0. What did I say? I said it was 239. All right. Now, the reason I was showing you how to figure out the broadcast IDs and we were showing you as well the network IDs is in order to do variable length subnet masking, I got to make sure that there's no overlap. So I need to know what the broadcast address is in that network that I created, so I know what the network ID is in the adjacent network that we're going to create with the next set of bits. All right, so that is our 16. Not a lot of waste there, but what we've done is essentially we've used, if you notice, we've used a variable length subnet mask, and let me fill this one in for completeness, 192.168.1, and that was 0.127. All right, and a slash 25. All right, notice what we've done here, right? we've varied the length of the subnet mask. There's 4 different subnet masks on this network now other than the /24. And what we've done is we've tailored them down to specifically what we need so that we don't have any of the waste within our networks. And that's what VLSM does. It allows you to shorten the amount of waste and to more efficiently design your networks the way you need to. And that's one of the reasons that they implemented VLSM. Now, one of the things that I also want you to keep in mind is that you have to have a routing protocol. Back to our routing protocols, because remember, our routing protocols are responsible for handling IP. You have to have a routing protocol that supports VLSM, right? RIP version 2, ISIS, EIGRP, BGP, OSPF, all of those routing protocols that we've talked about, they support VLSM. Keep that in mind, right? Some of the early, very early, probably outdated by now protocols that we would have might not support VLSM. This has been around since the 90s, so by now most of our routing protocols do. But again, just make sure that on the exam, if they ask you about variable length subnet masks, that you do know which of those routing protocols support that feature.
Great job, Wes. Thank you very much. Classless IPv4 addressing part 4. Make sure you watch all 4 parts because it's very important. And in fact, watch everything in the CompTIA Net Plus series while you're in that course library. Hundreds of other videos to help you go further. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. I'm Zach Memis.
And I'm Wes Bryan.
Thank you for watching. We'll see you soon.
Thank you for watching IT Pro TV.